Good day, all of you. Today's topic of discussion is EMP pathway. EMP pathway is an example of glycolysis. So, when you have the word glycolysis, glyco means carbohydrate and lysis means breakdown. So, in simple words, glycolysis means breakdown of carbohydrates. We have several pathways meant for carbohydrate metabolism, but for today's class, we will discuss on one of the major examples and a common example occurring across most of the living organisms, and that is EMP pathway. EMP pathway is named after three discovering scientists, and they are Gustav Emden, Otto Meyerhoff, and Jacob Paranas. In honor of their work, the pathway is called as Emden-Meyerhoff and Paranas pathway. This pathway is also called as fructose 1,6-diphosphate pathway because fructose 1,6-diphosphate is a very important intermediate in the entire pathway which marks the beginning of breakdown process. So let's move ahead to see how EMP pathway happens and what are all the reactions happening across the pathway. So the entire pathway looks like this, starting from glucose, and finally glucose gets converted to pyruvate. So let's have a stepwise description of all the reactions. Altogether, EMP pathway comprises 10 steps. The first 4 steps are categorized as preparatory phase reactions, wherein there is ATP utilization and low-level phosphorylation. In the next 6 steps, there is ATP generation, and these 6 steps constitute the oxidative phase of EMP pathway. In the oxidative phase, there is high-level phosphorylation reaction happening. At the end of the pathway, we shall calculate the net gain of ATP for each cycle of EMP reactions. So let's get started. The step 1 of EMP pathway is called phosphorylation. Phosphorylation is a reaction wherein there is addition or removal of phosphate molecule to a substrate. So when a substrate receives a phosphate molecule or it releases a phosphate molecule, either way the reaction is described as phosphorylation. Now in this step, what we call as phosphorylation, glucose is the carbohydrate available. Glucose will receive a molecule of phosphate and get converted or phosphorylated to form glucose 6-phosphate. This phosphorylation reaction is catalyzed by the enzyme hexokinase. Glucose is getting phosphorylated to glucose 6-phosphate in the presence of hexokinase enzyme. In this reaction, ATP is utilized. When we tell ATP is utilized, ATP is converted into ADP and inorganic phosphate. So in this reaction, we see the utilization of one ATP molecule. Moving on, we have step 2, which is isomerization. Isomerization is a reaction where there is conversion of one isomeric form into its respective isomeric form. So when we tell isomers, they have the same molecular formula, but they have different structural formula and therefore they behave differently. So here glucose 6-phosphate undergoes isomerization reaction and gets isomerized to form fructose 6-phosphate molecule in the presence of phosphoglucoisomerase enzyme. Step 3 is again phosphorylation. So here a second phosphate molecule gets added to fructose 6-phosphate molecule. So you see that fructose 6-phosphate is already having a phosphate, a second phosphate is getting added, and now the compound formed is fructose 1,6-diphosphate. This reaction is supported by the enzyme phosphofructokinase, and here again one ATP molecule is utilized. Step 4 is called cleavage, wherein fructose 1,6-diphosphate molecule undergoes cleavage in the presence of aldolase enzyme to form dihydroxyacetone phosphate and phosphoglyceraldehyde. Both DHAP and PGAL are 3-carbon compounds. So we See here that from glucose to fructose 1,6-diphosphate, all the molecules formed were of 6 carbon nature, but exactly here fructose 1,6-diphosphate marks the beginning of breakdown process, and hence the pathway is also called as fructose 1,6-diphosphate pathway. Moving on, we have step number 5, which is conversion. Here, DHAP, which is an unstable molecule, gets converted to PGAL molecule in the presence of triose phosphate isomerase. So from here on, it is the oxidative phase reactions that are happening for EMP pathway. Okay. So we now know that from the cleavage process, there is a direct release of PGAL. And from this step where DHAP gets interconverted to PGAL, there is one more PGAL. So altogether, from now on, there are two PGAL molecules which will continue the rest of the reactions. Step number 6 is dehydrogenation. Dehydrogenation is a reaction where hydrogen is released. So you see that there is loss of hydrogen. Hydrogen released by a substrate will be taken up by a high energy molecule like NAD, and NAD gets reduced to NADH2. So you are able to see that PGAL loses a molecule of hydrogen, gets dehydrogenated to form 1,3-diphosphoglyceraldehyde. This reaction is supported by the enzyme phosphoglycerodehydrogenase. The hydrogen that is released by PGAL is taken up by NAD, and therefore NAD gets reduced to NADH2. We write 2 NAD because we are representing that reaction is happening across 2 PGAL molecules. Now, NADH2 can be made equivalent to ATP molecules, as according to the formula, 1 NADH2 is equivalent to 3 ATP. Because 2 NADH2 are synthesized in this step, it means there is 6 ATP formation, or it is equivalent to 6 ATP molecules. Moving ahead, step number 7 is phosphorylation. But note here that a phosphate is not added to the substrate. Instead, the substrate loses a phosphate molecule. There is a release of phosphate molecule, and hence it is still a phosphorylation reaction. So 1,3-diphosphoglyceraldehyde loses a phosphate molecule and forms 3-phosphoglycerate in the presence of the enzyme phosphoglycerokinase. Here, this step is also called as ATP generation step because there are 2 ATP molecules directly synthesized in this step. Moving ahead into step number 8, 3-phosphoglycerate is converted to 2-phosphoglycerate in the presence of the enzyme phosphoglyceromutase, which means the phosphate group which is present across 3 carbon atom is now moving towards this second carbon atom, and therefore we tell 2-phosphoglycerate is formed. Thereafter, 2-phosphoglycerate is converted to phosphoenol pyruvate by releasing a molecule of water. So you see that 2-phosphoglycerate, there is a removal of water molecule and there is formation of phosphoenol pyruvate, in short called as PEP. This reaction happens in the presence of the enzyme enolase. In the last step, which is called pyruvate formation step, phosphoenol pyruvate is converted to pyruvate, and again 2 ATPs are directly synthesized. This reaction of pyruvate formation is catalyzed by the enzyme pyruvate kinase. So we see that across the 10 steps, we see glucose getting through the reactions and getting converted to pyruvate. Glucose, which was a 6 carbon compound, is finally converted to a 3 carbon compound called pyruvate. Pyruvate becomes the centralized molecule of carbohydrate metabolism. So just to have a recap, you can see how the first 4 steps are meant for preparatory phase reaction wherein there is ATP utilization. The next 6 steps contribute towards ATP generation. We now have to calculate for the net gain of ATP. When we count the number of ATPs utilized in the entire pathway, we have first step and third step showing the consumption of ATP. So 2 ATPs are utilized in the pathway. When we are counting the ATPs produced, ATP, direct ATP production happens in two steps. So we have 4 ATPs there. And then from the NADH2 molecule, we have the equivalence factor, and therefore we have 6 ATP molecules. When we add up all of them, we get 10 ATPs. Out of 10 ATPs, 2 are utilized in the first set of reactions, and therefore the net yield of ATP per cycle of EMP pathway is considered to be 8 ATP molecules. I hope this calculation part of net ATP yield is clear for all of you. So it is 4 ATPs produced directly, 6 ATPs through NADH2. Altogether it is 10 ATP. Out of these 10, 2 ATPs are consumed in the first part of EMP pathway. Therefore, the net gain after each cycle of EMP is 8 ATP molecules. So this is how the final look of EMP pathway is represented. I hope the entire pathway is made clear to all of you with a stepwise description. I hope there are no doubts, and I thank you for this session. Thank you one and all.